This is 5.10 linear combination, and we did skip 5.9 intentionally. Okay, so linear combination is like a systems of equations. So the system that we have is this right here. This is our system equation equal to this system. And graphically, if you were looking at this, we have, remember the number in front of, this would be an amplitude of a cosine plus an amplitude of a sine equal to the amplitude with a shift. All right? And if you notice, there's also 4 unknowns that we have here. Okay, so what you're going to be given is you're actually going to start with the left side. If you notice, that's what we have right here. So that's what you're always going to be starting with. And once you start with the left side, you're going to have to solve to get the right side. And if you notice, this right here looks somewhat familiar. It kind of looks like Pythagorean theorem. So C would be the next thing that you look for. And then you're going to use C in order to find your D. Okay? So that would be our process. All right, so let's try one of these. Do you notice it's not a proof or anything? It just says transform. So we're going to transform the left side in order to get the right side. Okay, so the first thing that I'm going to look at is that it's in the kind of the right order. So we start with a cosine and then a sine. So I'm looking at the thing that is in front, my amplitude, so that I can figure out what my A and my B are. So my A in this case, my A is a √3. And my B in front of sine is a 1. So from this, remember the next thing I need to go ahead is find my C. So I've got to find each one of my unknowns. So in order to find C, I'm going to set up my square root here. So it says A squared, so that would be √3 squared. And then my B squared would be 1 squared. Okay? And if I simplify that, 3 squared would be, or √3 squared would just be 3, and then 1 squared would be 1. So that's the square root of 4, so my C value is just 2. So I'm going to have A, B, and C. So the next thing I would do is let's try to find our D value. Okay, so I'm going to move over here. I've got a little bit more room. So I'm going to find cosine of D. And cosine of D is actually A over C. So A over C is going to be √3 over 2. And then sine of D is B over C. So B over C is 1/2. Okay, with this information right here, I'm actually going to try to find exactly what D is, because all I have found is some values, exact values to be exact. Okay, so if you notice, both of these are positive. So if I were to draw a triangle, both of these would be in quadrant 1. So if you were to fill in cosine would be 2 over adjacent over hypotenuse. Whoops, that's not supposed to be that. More like it, this would be √3 right here. And this would be 2, and sine would be 1 over √2. So this theta right here would be 30 degrees. So since we're working in radians, since this is an x, therefore D, my D value would be 30 degrees or pi over 6. Okay, so the last thing we've got to do, since we know all our values, is to fill in the right side of my equation. So I'm looking at this right up here. Okay? So I'm going to fill in C and a cosine and then x minus D. So my C value was 2. I've got my cosine. My x is just still plain Jane x. And then my D value was pi over 6. And I've got the right side of my equation. And that's what we've all got to do. Okay, let's try one more here. Okay, so this is what we have. What might be helpful is up in your equation, it does start with cosine, and then it has sine. So if it helps you to rewrite it, you can. You don't have to, though. So really your cosine, this is your A value, okay, right here. And then your sine is your B value. It's not going to change. So A in this case is -1 and B is 1. Okay, so let's find our C value. So we're going to square root the -1. That's squared. Doesn't like my squared. And then we're going to square B. Okay, so -1 squared plus 1 squared. So my C value is the square root of 2. Okay, let's go ahead and find out our cosine. So we're trying to find our D value now. So cosine of D. So remember, cosine of D, that should give us -1 over root 2. Okay, now let's find sine of D, and I'm just looking at the top of my paper. So sine should be B over D, so that should give me 1 over root 2. Okay, if it helps you out on this one, I'm going to fill in all students take calculus, because I've got some negatives here. So it's like cosine is going to be negative, so that rolls out this one and this one. So I'm going to be in one of these values. But sine has to be positive. So it looks like I'm going to be in this quadrant right here in order for both of these to be true. Okay, so since I have 1 over root 2 for both of these, that is going to be a 45-degree triangle. In radians, that is pi over 4. Since we're in this quadrant right here, that means I need to find out what I graphed in order to get that. So that means that D is actually going to be 3 pi over 4. And again, if it helps you to draw the triangle, go ahead and do so. That will be very helpful. Okay, so now we just need to look at the right side of the equation and fill in. So the right side says C times cosine, and in parentheses, x minus D. Okay, so our C value is a root 2. Our cosine. Okay, our x value. Our x value in this problem is actually a 5x. So I'm going to plug in a 5x right here. And our D value is 3 pi over 4. And this is our second part of our linear combination. Okay, on this last one, if you notice they've given us some restricted range that we're going to use. And this looks a little bit different, but this left side still is exactly the same. But they did say solve. Okay, so we're still going to have to start off the same exact way that we did. We're just going to have to go a little bit further. Okay, so let's begin the same way. Remember, cosine is the beginning part, so this is where you're going to get your A value. And sine is where you get your B value. Okay, so my A value in this case is 1, and my B value is going to be a negative root 3. Okay, so let's go ahead and find C. Plugging into my formula, so we're going to square this, and take the square root, and that looks like it's going to give me 2. Okay, let's go ahead and find cosine of D. Okay, cosine of D is going to be A over C, so that's 1 over 2. Sine of D is going to be B over C, so that would be a negative root 3 over 2. All right, let's look at all students take calculus and figure out where this one falls. Cosine is going to be positive, so that could be here or here. But sine needs to be negative, so that counts that out and that. So it's going to be in quadrant 4 right here. Okay, if you need to set up your triangle, cosine is adjacent over hypotenuse, and this is negative root 3. So that means this is actually a negative 60-degree triangle, or angle. Okay, there's a couple of ways you could do this. D can be negative pi over 3. If you don't like working with that negative right there, you could find the angle in order to go around positive, and that is 5 pi over 3. I just went blank. C cosine x minus d. Okay, so my C is 2, my cosine, and my x value, if you notice, my x value here is 2x, and then my d. So you get to pick which d. Personally, I'm going to pick this one because it looks smaller to me, even though it's a negative. When I plug this in, it's going to become positive. So it didn't seem like a big deal to me. Now, what is so different about this when it says solve? This is where it's going to change because it says solve. You notice we haven't used this root 3 yet. Now, I'm going to use my root 3 because I'm actually solving. Okay, so this is where our general solutions are going to come back in. Okay, so I'm going to try to take this slow so you remember what to do. So general solutions is when you solve for x. So what we need to do first is divide everything by 2. So that means this would be cosine of 2x plus pi over 3. And that's going to be equal to root 3 over 2. Okay, so we've isolated the cosine. So now I can divide by cosine or move my cosine over. So that's going to be 2x plus pi over 3. And that's going to be equal to my arc cosine of pi over 3, or root 3 over 2. Okay, at this point, you need to find out what angle this is. So you can draw your triangle of arc cosine. You know that's going to be positive, root 3 over 2, and find out what angle that gives you. And of course, that's going to give you pi over 6. Okay, so this is where we write our general solutions. So this gives me 2x plus pi over 3, and that gives me pi over 6. And this is where we add 360 or 2 pi n. Okay, this is where some people mess up. We wrote one general solution. I'm going to write my second one right now. Okay, so I figure out I've already written one of them here because cosine is positive. Since cosine is also positive here, my second triangle is going to be drawn down here as well. Okay, so since pi over 6 was here, you may do the positive angle all the way around, or I think it's just as easy to go negative here. So I'm going to do the negative angle, so 2x plus pi over 3, and I'm going to say negative pi over 6 plus 2 pi n. Okay, so I've got both my equations in order to solve now. So right here, what I need to do is divide by 2 on everything. Whoops, no, we need to subtract pi over 3, sorry. Okay, that's order of operations. So pi over 3 subtracted from pi over 6, you're going to do a common denominator. That leaves me with negative pi over 6 plus 2 pi n. Now we need to divide by 2. So my answer here, or my final general solution, is negative pi over 12 plus pi n. Okay, let's do the same thing here. I'm going to subtract pi over 3 from both sides. That gives me 2x equals negative 3 pi over 6 plus 2 pi n. And now dividing by 2 on everything. Actually, I could have simplified this, but I'm going to go ahead and simplify now. Gives me negative pi over 4 plus pi n. And this gives me my 2 general solutions. See, we can plug in a 1 here. So that gives me 11 pi over 12. And I can plug in a 2 to get 23 pi over 12. I can do the same thing over here and plug in a 1. That gives me 3 pi over 4. And I can plug in a 2 to get 7 pi over 4. And none of these are over the 2 pi.